Okay, for number 4, we're estimating the area under the curve from -2 to 2 with right-hand Riemann sums and 16 equal subintervals. So first thing we want to figure out is how big is each subinterval? That's the delta x. All right. How big is the subinterval? How big is the base of each rectangle? So we take b minus a over n. So 2 minus -2, 2 plus 2, all over 16. So we end up with a base of 1/4. So that means for our first subinterval, we're going from -2 and then going over 1/4, which would bring us to -1.75, and then over 1/4, and so on. So we're going every 1/4, we're splitting up this region into another subinterval. And that'll end up giving us 16 equal sized subintervals along the x-axis. And we're doing a right-hand Riemann sum, so if we look at intervals, we're taking the right side of the interval to create the height. So from -2 to -1.75, we'd be putting -1.75 into the function to find the height of that rectangle. And then -1.5, then -1.25, then -1, and so on. So we're taking the height from the right side of each rectangle, or right side of each interval. So we want to find the area of all 16 of those added up, but we don't want to physically find the area of each one of those 16 rectangles. So we're going to use these formulas to help us. So we've already got the 1/4 here. Now we want to find x sub n. That's the value that we're plugging in to find the height of each one. So it's going to be a, which is -2, plus delta x, which we established was 1/4, times n. Or maybe more commonly we would write it as 1/4 n minus 2. Alright, so that's our x sub n. So our first rectangle, if we put 1 in per n, that gives us -1.75. That's the x value we're plugging in for the first rectangle's height. For the second rectangle, when n is 2, we put 2 in there, we get -1.5. That's what we're plugging into this function to find the height of the rectangle, and so on. Well, now we can take both of these and substitute it into this sum to set up our equation. So we're taking the sum from n equals 1 to 16, right? The total number of subintervals, total number of rectangles. Then we're taking the sum of delta x, which we established was 1/4, times f of x sub k, which we get by taking, and that should be x sub n. We get that by taking x sub n and plugging it into the equation. 9 minus 1/4 n minus 2 squared. This is the height of each rectangle, this is the base of each rectangle. This adds up all of those together. So if we want to go ahead and put this in our calculator, we're going to second stat, math, number 5, sum, second stat, ops, number 5. We want to put in this expression, so we have 0.25 times, in parentheses, 9 minus, parentheses, 0.25x minus 2, parentheses, squared. And then we want to close out the parentheses for the whole thing, because 1/4 is getting multiplied by all of this. Comma x, comma 1, that's where we're starting from, comma 16, because we're going to 16 equal subintervals, comma 1, because it goes up by 1 every time. And we get 30.625. And when I say it goes up by 1 every time, I'm not talking about the base here. I'm talking about the ends. We're talking about first subinterval, second subinterval, third, fourth, fifth, all the way up to 16. So for this one, we get 30.625 for our answer.